Welcome to Understand the Math. Have you ever been given a function and asked to evaluate it for a specific input? Whether it's from a formula, a table, or a graph, understanding how to evaluate functions is a key math skill. In this video, I'll walk you through the step-by-step process so that you can know exactly how to evaluate functions. Let's get started. To evaluate a function simply means to find the output for any given input. A function takes an input, applies a rule, and then gives an output value. We often write the input variable as x and the output variable as f of x. X is the independent variable, and then y, or f of x, is the dependent variable. Let's start by learning how to evaluate a function using a formula. In our first example, our function is equal to 3x minus 2. To evaluate this function, we're going to substitute in different values for x and then simplify. When x is 3, our function is equal to 3 times 3 minus 2, which is 9 minus 2, which gives us a function value of 7. That's our output value. If we put an input value of 0, we're going to get our function is equal to 3 times 0 minus 2. That one's actually easier, which just gives us 0 minus 2, which is minus 2. Let's now try a negative number. We're going to plug in x is negative 2. So wherever we see an x, we're going to substitute a negative 2. And then we have to subtract another 2. Simplifying this gives us a minus 6 minus 2, which is equal to a minus 8. Now here's the hard one. We're going to evaluate f of x plus 2. My students have always struggled with doing this, so I'm going to try to explain this as clearly as I can. Wherever you see an x, you're going to plug in x plus 2. Let's go ahead and do that. So we have a 3, and then instead of an x, we're going to plug in x plus 2, and then we have a minus 2. Let's now simplify. Multiplying the 3 times x plus 2, we have 3x plus 6 minus 2, which gives us a final output value of 3x plus 4. Notice how when we plug in a number, we get a single value. But when we plug in an algebraic expression, such as x plus 2, we end up with an algebraic expression and not a number. You may want to pause the video and see if you can complete our second example. F of 3 is going to be when we plug in 3 for x, so this is 3 times 3 squared plus 1. This is going to be 3 times 9 plus 1. Which is 27 plus 1, and gives us an output value of 28. Now let's evaluate f of 0. We have 3. We're going to plug in x is 0, and we'll square that, add 1, and this just gives us 0 plus 1 for an output value of 1. Now let's do a negative. We're going to plug in x is negative 2, so we have 3 times negative 2 squared plus 1. The hard part with this one is you have to remember that you are squaring the negative. So this is going to be 3 times negative 2 squared, which is 4, plus 1. And this gives us 12 plus 1 is equal to 13. Let's now do one with an algebraic expression. Let's evaluate f of x plus 2. This gives us 3, and then instead of x, let me go ahead and highlight this so you can see what we're doing. Instead of x, we're plugging in x plus 2. So we have an x plus 2 quantity squared plus 1. And this gives us 3 times the quantity x plus 2 squared, and this is going to be x squared plus 4x plus 4 plus 1. Let's go up here and simplify this. This gives us 3x squared plus 12x plus 12 plus 1 for a final answer of 3x squared plus 12x plus 13. If you need a review of how to complete this square, check out my video called Squaring a Binomial. The link is listed in the description. Let's now look at how to evaluate a function from a table. Let's look at our first example. To evaluate f of 3, what we're going to do is we're going to go up to our table and locate 3, and then see what f of x value is associated with 3. And it's equal to 2, so we can see that f of 3 is equal to 2. To evaluate f of 8, we do the same thing. We go up and we find 8 in our table, and we see what the corresponding f of x is. It's equal to 1, so f of 8 is equal to 1. Lastly, let's evaluate f of 12. We go up to our table, find 12, and we see that the corresponding f of x value is equal to 8, so f of 12 is equal to 8. Let's now look at our second example. You might want to pause the video and see if you can complete this one on your own. A of 1 is going to be equal to pi. A of 5 is going to be equal to 25 pi. And then lastly, a of 9 is going to be equal to 81 pi. This table tells us the relation between the radius of a circle and its area. Finally, let's evaluate a function from a graph. Given a graph of f of x, we have two examples here of that. We find an input x, trace it vertically up or down to the function, and then just read off the corresponding y value. Let's start with f of negative 1. If we locate x is negative 1, we go down vertically and we can locate the y value. That y value is negative 1. Our next point is x is 0, and you can see that f of 0 or y is equal to 0. And then lastly, f of 2 is located here, and it's equal to 2. Let's now look at our second example. The first point we're going to evaluate is f of negative 1. Notice when we go up to our graph and we look at negative 1, there is no graph at that point. This means that f of negative 1 is undefined. That just means that there's no corresponding y value for the x value of negative 1. Our next one is f of 0, so we go to x is 0, and we see that our function is also 0 at that point, so f of 0 is equal to 0. Lastly, we're going to evaluate f of 1. We go over to 1, trace up to the graph, and we see that our y value is equal to 2, so f of 1 is equal to 2. Evaluating the graph of a function is all about reading values accurately. You now know how to evaluate functions from a formula, a table, and a graph.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.